In this video, you'll learn how to identify and predict products of a simple double replacement reaction. Let's first talk about a double replacement reaction and its definition. So in a double replacement reaction, you have ions of two compounds that are going to exchange places with each other in order to form new products. The general formula for a double replacement reaction starts off with two compounds. In the compound, when the reactants are going to react with one another, the two ions are going to switch places in order to form new products. A quick summary, you can see we always start off with two compounds. In a compound, the cation is always first, followed by the anion. In a double replacement reaction, the cation from the first reactant is going to bond with the anion in the second compound. Then the cation from the second reactant is going to bond with the anion from the first reactant, ultimately forming two new products. Don't forget that whenever you're considering new products, you have to always look at their charges in order to make sure that the charges are balanced and neutral. Let's take a look at our first example. Potassium iodine reacts with lead 2 nitrate. When you write this in a chemical equation, you can see that potassium iodine is going to be the first compound, and that's going to react with our lead 2 nitrate. So we know in a double replacement reaction, the cation and the anion from the first and second compound are going to bond with one another. And the cation and the anion from the second and first compound are going to bond with one another. So if we take a look over here, potassium is now going to bond with nitrate, and we're going to have lead that's going to now bond with our iodine. You have to consider the charges in order to make our new products. So right here we have potassium with a positive 1 charge and nitrate with a negative 1 charge. That's going to form KNO3. Lead 2 iodine is going to form PbI2. The last thing that you need to do is just balance the chemical reaction. So you can see we can put a 2 in front of potassium iodine to balance out our potassiums and our nitrates on both sides of the reaction. Let's take a look at our second example. In example 2, sodium chloride is reacting with magnesium oxide. So you want to first start by writing out the two compounds that are going to react in our double replacement reaction. Then we know that our sodium is now going to bond with our oxygen, and our magnesium is now going to bond with our chlorine. They're going to switch places with one another. Therefore, we can make new products. Sodium has a +1 charge, oxygen has a -2 charge, and magnesium has a +2 charge, and our chlorine has a -1 charge. When we're making new products, we have to balance out the charges. So our compound is now going to look like Na2O. And on this side, magnesium and chlorine is going to form a compound which is MgCl2. The last thing you need to do is just balance out the chemical reaction. So you can see we have two sodiums on this side, so we need to balance that out on the left side. When we put a big coefficient 2 in front of sodium chloride, that also fixes our chlorine, and now this is a balanced chemical equation. Let's take a look at our last example. Sodium carbonate is going to react with hydrochloric acid. So we know sodium carbonate is written Na2CO3, and because we have hydrochloric acid and it's hydroic acid, it's going to be HCl. In a double replacement reaction, the cation is going to bond with our anion over here. So we're going to have sodium and chlorine going to bond with one another, and our hydrogen and our carbonate. So in this case, hydrogen is going to be considered a cation. Whenever that happens, we need to balance out the charges. So sodium chloride is going to form NaCl, and our H and CO3 is going to form another acid. And we can write that as H2CO3. The last thing that we need to do is just balance out the equation. So we need to put a 2 coefficient in front of hydrochloric acid in order to balance out our two hydrogens on this side. Then we can put a 2 in front of sodium chloride to balance out our sodiums and our chlorines. Now you have a balanced chemical equation. And that concludes our video for today. Thank you for watching.